Hello, everyone.
Hello.
Yeah. So I think Eddie sent a note that he won't be able to join today. I think it's daughter's high school graduation day. So
Is the meeting canceled or we'll continue on? I believe Donald sent the email for a few
I think
items that we'd like to discuss.
Yeah, I think we will continue. So I haven't seen the agenda, or at least but I know Hassan was going to present something as per Eddie. I see Hassan on the call. And if there are other topics, I think we should definitely get to them as well.
Yeah, hi Praveen. How are you? Hello, everyone.
Good. How are you? Yeah, hey.
Yeah, so actually, there were two questions I see from Donald over the email on that work group, but I don't see Donald here. Maybe we can wait for a couple of more minutes.
Sure, yeah, I think.
Yeah. And maybe you can discuss those first, and then as Eddie requested, I can share some of the details from my experimentation that I was doing on SONiC. Just an FYI, actually.
Sure.
I still do not see Donald here.
James,
Okay.
I think
Do
we
you
agreed
want
to
to? Do you want
record
to?
the meetings and start them somewhere, right?
Yeah. Do we want to get started then? I can try to record it. I think I should. Okay. It says please ask the host to give you permission to record.
It's recording. When you join, it says it's recording.
Okay, recording on. Okay, that's good then. Yeah.
All right. Let me share my screen so that we can get started. Okay. Okay, so out of those two topics that Donald was sharing or made his comment or that email, the first one was he wanted to understand why this patch ignore route from default table is required. So the specific patch is if we have a check in Zebra that if the route is being sent to the FPM SIND is from the default table, then don't send it. So this issue came up. So I was in touch with Yanzhou, I think, from Microsoft, and Guhan also actually was trying to explain what was happening there. So this diagram tries to explain the tables. So as we know, kernel has multiple routing tables, like default table, main table. There's a local table like 253, 254, 255. These are the table IDs. And any route that the routing daemons in, say, FRR, they install, they actually go into the main table in the Zebra, which corresponds to the main table that is maintained in the kernel. So Zebra, in a sense, has same mapping of the table. So there's a table, default table in Zebra, which corresponds to the default table that is near kernel, and also the main table. The issue here is that the FPM syncd, when it is getting the update from Zebra, it does not get these table IDs. Instead, it gets the VRF name. So as you can see from this diagram, what happens is if the route is coming from, say, the default table, which was essentially the default route was installed by host config D, that will also go as a default route. And also any route, say default route added by BGP, will also go to FPM syncd as a default route. So one update may override the other. So in a sequence where, say, BGP added a default route, and then host config D added another default route, and then because of some reason, this host config D is removing the default route. In that case, you will see that the default route goes missing from the hardware and the app DB, while the show IP route is still showing the BGP route. So that is the reason why we wanted to keep only the main table as the main source of the routes. This route, which is installed by the host config D, is only for the management connectivity. By the way, this does not have the management VRF configured. That is why we are getting into this problem. So we cut this path off so that the main table is the only source. I hope this clarifies.
I guess, can I ask a question? Why aren't you passing down the table ID with the, because it's table 253. We should be passing down the appropriate table instead of, and then FPM syncd can do whatever with it. So that part I'm a little confused about.
Yeah, so there was, okay, so I think there is some history with this VRF. There was another patch, let me see. SONiC.
Donald, if anything, I would expect the route to go into Zebra, and then based on administrative distance, Zebra to tie break which one should go into FPM, right? That would be the
No,
normal
so
order of events.
the point I'm making is that if we are passing down the default route from table 253 as if it's in the main table, that's a bug and we should fix it. And that's a separate issue than the patch done.
Yeah, so you're right. I mean, if we can pass the table ID as is, then we can make the same decision that we are doing in the Zebra to discard this route, and we can discard in FPM syncd. This is what I think you're also saying, right?
Exactly, because from a Zebra perspective, we should be telling the truth about where this route lives and what table this route lives. And if we're not, that's a bug in Zebra, and just throwing it away is not the right, well, I mean, it is a solution, but it's not the correct long-term solution for Zebra.
Yeah, I agree. I agree. In fact, I was trying to find out another patch that was added where we hit this. So originally, I think Zebra sends the table ID, but we wanted to pass the VRF because each table has, yeah, I'm just trying to find out the patch here. I cannot find it here. It was in the very initial phases when the VRF was added. I think what we can do is we have to add another TLV or another attribute in the same route to carry both the VRF as well as the table ID, because we need both of these.
You don't use namespaces, correct?
No.
Well, they're
So
kind of,
Arson, I think the history behind introducing the default table is basically, well, originally SONiC did not have any management VRF feature. So that time, we had a requirement to have a default VRF, right? Default route in management context as well as the default VRF context. So in order to get the workaround for that problem, so I think Microsoft went ahead and used the default table. So, but after introducing the management VRF, we should have got rid of that, default table completely, but somehow because of the backward compatibility reason, it's been continuing. I don't know, it's high time right now to get rid of the default table completely. Whenever we need, separate default routes in different VRFs, I think we need to push the solution to use management VRF.
Yes,
the other question I
Venkat,
have-
I agree. I agree that management VRF is one solution,
Right.
but as far as I know, Microsoft is not using the management VRF in their network.
How do you plan to handle IPv6? Because if host config D pushes the IPv6 route into table 253, how do you plan to actually do any type of forwarding without the appropriate rule in the v6 rule table?
So there is a IP6 rule table, right? So today we basically there is a rule getting added. IP rule add anything, any traffic, going with source of the management IP. It goes to the default table for further lookup. I think the same thing is happening for the IPv6 traffic as well.
Yeah, so so by default, the Linux kernel has a rule for v4, but it does not have one for v6. So are you
I
installing?
believe, yeah.
Does SONiC add in the rule manually? Okay.
Yeah, as part of the OCFGD, yes. So I brought up this point multiple times, and because there are deployments with this solution, the community pushed back saying we can continue to have this default table. So if this table is really affecting FRR behavior, I think ignoring it for now is okay. But I think the right fix is to
No, I was asking these questions because I didn't understand what the goal of the patch was, A, and B, we can show a crash with that patch. And before I did any fixes, I was trying to understand the underlying architecture because maybe we were doing the wrong thing somewhere else. And so that was the point of the question. I just didn't understand what the goal was or what you were trying to do. I understand better now. And the real sticking point is that we pass, FRR passes down the table ID, I'm sorry, the VRF ID for VRFs instead of the table ID. No, but I thought we installed with the table ID.
Yeah, this is the patch, Donald, actually. I think this is what you're referring to here, right?
Yeah, so that, yeah, that's the crux of the issue right there. We're passing the table ID down,
correct,
expecting the underlying, and this patch caused the problem. Got it.
Yes. Yeah.
What was the decision point for passing the VRF ID, not the table ID, if I may ask?
So this was because FPM-SIND maintains the interface table database. It does not maintain the VRF database based on the table IDs. It maintains based on the VRF IDs, which is nothing but the interface ID of that VRF L3M DevNet device.
How do you expect to handle a use case where someone wants to use one of the other 4 billion tables that are available on Linux for routing, and they don't want to use a VRF table? There's use cases for that.
You mean to say the namespaces?
No, I can use, there's 4 billion tables in Linux. I can use whatever
you're saying this.
want.
I can create. Anyone can create arbitrary tables and then insert it out. You're saying, right?
Yep. How do you expect to be able to handle that?
Yeah, I mean that. Yeah, I would say that use case is not there right now. Yeah.
Because it's going to
But
break.
but Hassan,
If someone uses the IP import table functionality in Zebra, it's broken. And there's actually kind of valuable, like, sometimes people are using it for when they're using things like Bird, and they want to be able to communicate between two different routing processes. and they're using other tables. That's one. And I've seen other people use like random tables for things like PBR and stuff like that. This patch here is going to be a real problem, in all honesty.
Yeah, I agree. And I agree that, the same database that is there in the FPM-SINCD, which is based on the IF index, we can convert that into a table-based database with a key as table ID, because netlink dump will have the table ID as well.
Yeah, that is what I was about to mention, Hasan. Because if you get the table ID, we should be able to get the VRF ID name or VRF name from that,
Correct.
right?
Correct.
So
correct.
if we get like other than the reserved values like 255, 254, 253, whatever, if we get other than that, maybe we can get the VRF name from that, and then we can handle it. For all other
That's right.
things, I think main table is meant for default route, but default VRF, but all other tables you can ignore if you don't find any use case for SONiC.
Correct. Yeah, I'm not sure whether we have anyone from NIFOS here in this call, but this patch was added by NIFOS when they were adding the VRF functionality in SONiC.
Yeah, there's also
Along with-
functionality in BGP to say, take this BGP route and put it in this particular table too. That's straight in FRR right now. So
Yeah, so
doing that is gonna
Donald,
you're gonna call-
I understand where you're coming from. So one difference here I would say is that SONiC configuration is all driven from the SONiC configurations like config.db or click, those sort of things. The users are not encouraged to directly go to the Linux kernel and modify, because
but they do.
it
Let's be
might
realistic.
stay.
They do.
Sorry,
They do. I mean, I know for a fact that our sales engineers are selling solutions where they're directly installing VTY shell commands.
Yeah,
via
VTY
So-
shell is anyway FRR, right? It's not the kernel. I mean, you are not actually creating a new table. So think of like this: even if you create a new table, that table does not exist in the hardware, and the routing in the forwarding plane will not work, right?
My point is that you're going to have a disconnect in the control plane and the forward plane then.
Exactly, and that is why
if it's not documented, people are going to expect the FR features to work, and that's my point.
Yes, it's not documented that anything that is shown in the FRR configuration is not relevant for the SONiC.
I guess I'll say the bit I think is important here is that people are going to use the features, and they're going to be very hard to debug when all of a sudden routes start showing up in the default table when they put them in table 50 or table 200, or I'm trying to use PBR when tables go 10,000 and to whatever. So
Yeah,
there's
I mean, if this something like this happens, that the table is somehow treated as belonging to the default VRF, right? This is what you're referring to, that I can create
that
arbitrary
patch that
table.
was just shown does exactly that, though. It takes everything that's not on a particular VRF, it puts it in the default table, right?
Yeah, you're right. Yeah, correct. And
So if
as
I put routes in table 99 or table 10,000, all of a sudden they're going to be showing up down on the ASIC in the default VRF.
I agree, and that is where I was saying that the users are not encouraged to create the table, arbitrary table on their own. The only way to create these tables is using the VRF.
I disagree with that statement, because I like off the top of my head, PBR creates tables that it uses. I can do local import and Zebra. That will just a random table between 1 and 255. I can in BGP, I can tell the route to go into any particular table. So there's just 3 ways off the top of my head. And I could probably, if I spend a few more minutes thinking about it, I could probably find a few more. That's
Of
just
course,
default
of course,
FRR.
of course. I mean, there exists a ton of ways how to crash FRR by just,
That's not FRR crashing. That's
doing-
the FPM-SINCD doing the wrong thing.
Sure. Yeah. Yeah, maybe once we change that FPM SING-D design, both of these patches, one is this one, which is, where's this called? Yeah, use VRF ID for VRF not table ID patch. And the other one is the default VRF that we were just discussing.
But
No,
Donald,
fine.
are we saying that we would like to extend the concept of both the tables and VRFs into FPM SING-D, like, and make it similar to what, essentially extend those capabilities that Linux kernel currently supports, where you can either create VRFs or IP tables for either isolation or things like PBR, extend that into FPM SING-D and into SONiC, or
Yeah, it's just something needs to be done sometime in the near future is what it boils down to. I shouldn't say near future, sometime in the future it needs to be done. Because otherwise you're going to have some really, really weird behavior.
right. I guess if we frame the problem that way, which is essentially Linux kernel has a few ways of, has at least, two, maybe three, if exclude the namespaces, at least two ways of doing route isolation, whereas today in FPM SING-D and the rest of the SONiC, there's only one, which is VRF. So I think if we frame the problem in such a way that we essentially want to extend the concept of tables into FPM SING-D and hence into SONiC, then a lot of these things will fall in place. At least we'll be able to define what the desired behavior would be, right?
It's not only the FPM SING-D, Praveen. If you see, table ID is, is kind of a VRF, right? And unless you create a VRF, you won't get this functionality in the hardware. So even if somebody creates a new table ID, what is there in the hardware?
Right. And what I meant by FPM SING-D is like from FPM SING-D and all the way below. So I just stopped stating that there. What I meant is essentially taking the current behavior of Linux kernel and extending that into SONiC and SAI and into the hardware. Because the first question is that the desired behavior? And if it is desired behavior, then what are the specific work items that need to be done, and how? I think if we frame the problem from that standpoint, then maybe some of these questions, both now and in the future, it kind of creates a set of guidelines for how people would want to do this. Because today, clearly, I mean, as Don, you're pointing out, there is a disconnect where the SONiC and SAI in the hardware world pretty much lives by VRF, whereas Linux kernel has more than one way of doing that. So is that a use case that we want to take and address as part of this work group then?
I'm not sure we have such a use case, Praveen, at this point. We are, at least for SONiC, having separate tables for PBR and all those things. I don't see any, near-term use case.
Okay, so is maybe we
so
can
basically
just...
the tables were present in the kernel, right? So VRF leverage those tables to give the isolation for routing tables, routes, right? So I think, if we can revert that patch, whatever we have in the SONiC FRR, it's going to cleanly give us the table IDs all the way to FEM SING-D. And then there, instead of, whatever the table lookup by VRF added in this patch, right, in the SONiC FRR, we just need to introduce that in the FEM SING-D, if not already present.
Correct. And dropping of the routes not belonging to the main table,
right,
instead of happening in the Zebra, it will happen in the FPM SING-D.
It
but
can
we're not
happen
getting
in
away
FPM
from this.
SING-D.
Yeah.
Right.
We are not getting away from this behavior. This is what I'm trying to say.
Yeah.
Correct. Yeah. Essentially make it more of an FPM SING-D and SONiC problem rather than Zebra behavior.
Correct.
Right.
Correct.
Yeah.
Okay, so I believe somebody is taking minutes today.
I believe Eddie was mentioning someone from Alibaba were going to take the notes, but if not, I can jot down a few.
Sure.
Okay.
Okay. Is there anything else before we move on to the next topic? So Donald, there was another topic that you were saying, when are we going to upgrade?
Actually, I wasn't quite asking that. What I was saying was there's a lot of bug fixing going on in FR. And I keep getting pulled into SONiC issues found on 822 that I've already been fixed. And instead of being reactive, I think it might behoove the SONiC community to be reactive, to be proactive, and look at what actually have like maybe a monthly meeting, or I don't even know how, I don't fully understand the SONiC community, how it works, but I think it would behoove the community to look at what's been going in over the last, month chunks and go, hey, this fix, that's a problem our customers are probably going to see. We should backport it ourselves. Because especially since if you're not planning to upgrade FRR in lockstep with upstream. Mainly because I think there would be less time spent debugging problems, or if I hadn't have fixed a couple of the problems I was asked to look at in SONiC over the last couple of weeks, it probably would have taken me a lot longer to figure out what was going on and fix it again, versus just knowing, oh, there's a patch here, let me go grab it. And I think there's value in having the community look at it and go, oh, these 50 commits in BGP, 3 of them are important to us, let's grab them now.
So what is the most stable release after 8.2.2 that you can see? No.
8.5. But that's a different problem. That's a full upgrade. I'm saying bug fixes only. I mean, for all intents, I mean, I hate to say this, but SONiC's forked. If you're not following latest upstream, you're forked. And then how do you manage that? That's what I'm trying to advocate for here, is how do you manage the life cycle of our fork so that we can proactively stop problems for ourselves before they become a real problem. That's all I'm saying.
Yeah. Yeah, actually this was, so Rita, do you have insight into, I know that, after SONiC moved to Linux networking, things have a little changed. And I'm not sure who is now deciding, or what is the deciding factor to move to the next FR version.
Actually, it's
Yeah.
I think it's up to the community collectively to propose, right? So, for example, start of the release process or beginning of the release, then there's a content collection, right? So actually, for example, we could say every major release, every SONiC major release, we upgrade to a FRL, either major or a maintenance release. I think that we could do, right? But I think that's one way how we could upgrade FRL in the main line, like a master branch. I think another question is, what about the release branch? Do we want to upgrade FRL? That one, I think it's more challenging. Yeah, so I think if it's some maintenance release, or that has already a good number of FRL fix, we could consider doing that in the SONiC major
No, I think
release.
we don't upgrade in the
Rita,
major release. We always upgrade in the main branch. And yeah, so that's how it is.
Right.
Rita,
So
to Donald's point, we've been running bugs in production. If we could have a list of critical bugs that need to be backported, respectively of release that is coming together with SONiC, we might actually avoid this kind of situation.
Yeah, I don't disagree. It's just that if we have a lot of devices already running BGP stably and not necessarily run into these bugs, at least Microsoft would be very hesitant to add change. Yeah. That I think for the production ones, that's what I meant by challenging. Yeah. Yeah, I think probably people also have seen that the changes, any change coming in while the intention is good, but sometimes there's also an intentional breakage, right? And yeah, so that's why when things are already running, already released, I think we have to, well, but indeed, there was a few fixes that that were done in the production branch, or release branch. Yeah, I think it has to be case by case, and cannot be a general statement that there's 10 important bug fix and let's upgrade it. Yeah.
Yep, maybe we can take this in a bigger forum, and then decide collectively. Yeah.
Yeah, Hassan.
Yeah.
Can you hear me? Yeah. So in fact, I
Yes.
don't think there's a regular cadence, in terms of community release that it mandates a FR release in every single cycles of these community release. But I think it might be a good thing to, at least get a consensus on the working group and bring it back to the community or the TSC to basically, set up a cadence for FRR upgrade. For example, in these particular release 2020-05, I don't think there's an element for FRR upgrade. I think if the working group can set up some guidance, hey, for every single release, we should consider doing this. And then what is the criteria and what is the version that we should go up to? I think if we can set up some guidance in the working group, then we can bring it back in. Because back then when we do the FR upgrade from Broadcom, right? Which is the one that you actually did. I think we also struggling to determine, which is the right version to go. Again, I mean, I think if we can set up some, general guidelines for that, then that can be helped by the community release program.
Yes. The question is which working group you're looking forward to making this decision? This routing working group or?
Yeah. So I think we should come up with a draft from the routing working group that since we're all in here, and then since this is actually a proposal and issue that we have been discussing, and if we can come up with some guideline, and definitely circulate it back to the TSC.
Yeah, makes sense.
Okay, thanks.
Thanks, Adam. All right. Okay, I think we have less than half an hour remaining, so we can move on. Does that somewhat answer your concern, Dolan? Sharp?
Does it answer my concern? No, but that's okay. It's really, I mean,
Yeah.
I just think there's value, and I'm not hearing people agree, so that's fine.
Yeah, it's just that, we don't have the insight right now. And you could hear from Rita as well that, it's on a need basis. Right now, it looks like nobody has felt a need, and that's why we are still stuck with 8.2.
Well, again, I'm not advocating changing the release number or going to a new release. I'm saying, look at the patches that are true bug fixes that go in and go, you know what, that one's really important. They found a true hole. We should fix it. That's what I'm advocating.
Okay.
Hey, maybe what we are missing from the SONiC community is do we have some regular process to understand or get notified on important bug fix, or from the FRL community? Or every time there's some release, then somebody like I don't know, Hassan or FRL expert may want to maybe we can set up some cadence to review those bugs, right?
Yeah, I think, bugs are anyway on a need basis. Only if somebody is getting into those issues, it's a requirement from their side to actually either patch the FRR or migrate to a newer version. But if somebody is already running an existing FRR and they are not exercising those use cases, then they may not feel any need. That's what is happening here, it looks like. But yes, I think,
but it looks like there could be, let's say if there are 20 bug fixes, sometimes maybe 1 or 2 out of this 20 we have use case, maybe we should still consider taking those, right? But then I guess what the point was, how do we make it more proactive in terms of addressing issues? Then I think we can set up some process for that.
Yeah. I think, Adam, you have an AI right here.
Sorry, I'm missing the last part. So what they're saying is that?
So, the AI is that we should bring this up in the SONiC Foundation to come up with the process for the FR upgrade.
Yeah, so look, I think this needs to be at least hash out and agree in the routing work group first, right? So then this is something that I think the routing work group should come up with a process. Then we then collectively, if we all agree within the routing subgroup, then this is something that we can bring it up into the TSC.
Quick question: are we looking at vulnerabilities as well? I mean, differentiating bug fixes for functional items versus vulnerabilities. Are we searching for vulnerabilities or having some type of cadence to handle vulnerabilities?
Yeah, I would say vulnerabilities are the primary candidate to be backported and patched as and when those are the fixes are available.
Sounds good.
Yeah.
I believe
we can do this
because we are using a lot of open sources, not just FRR, right? There's a Team D and other kernel patches and a lot of things are happening, right? I think we need a general guideline. If at all something, some bug fixes or vulnerabilities are encountered in one of the open source that we are using in SONiC, I think we need to have some process.
Yes.
How are we gonna
Yes.
bring it into SONiC, right? So yeah.
Correct.
So Hassan, I would suggest this.
Yeah.
Let's maybe from Broadcom, let's come up with an initial proposal. Basically, we're looking for a process, right? In terms of two things. In terms of community release, what's the guidelines for FRR upgrade? That's number one, and also in between the release or in the beginning of the release, in between the release, what's the process of backporting some of the fixes coming from FRR, which is deemed critical to the production of SONiC, right? So then we can probably draft up a initial guideline. Yeah, and then
maybe in the next
we can
next
circle.
meeting we can, correct.
Circle it
next
back
meeting
to
we can,
the.
correct.
Yeah, circle it back to the routing group. Let's get a consensus. I'm sure there will be more input from the team. Then once we consolidate everything, then that would propose so that we can send it up to TSC to get the approval.
Yeah, makes sense.
All right,
Makes
thanks.
sense. I think next working group, maybe we can have some proposal. Next meeting. Thank you. Okay, let's move on. So Eddie asked me to actually share some of the observations from Broadcom side. So I have a few slides to just talk about. This is like route scale and the kind of issues that we face during the route scale. So it's a rough, you know, just few notes from here and there, and then it gives actually pretty good insight into what is going on. So what we did was we have this kind of leaf spine topology, and we were trying to scale to 1 billion routes. So these are like Ixia devices. These are leaf. This is spine. We have a specific platform like Trident, Trident 4 based platforms, which have the ability to support more than 1 million routes, both IPv4 and IPv6. So we use those platforms here. And as you can see, these are all running eBGP, FRR, SONiC, and 250K routes are being energized from each of these TGN ports. Times 4 is actually 1 million. So total routes in the network is like 1 million routes. Let me, okay, so sure, it went in. There were a few hiccups, platform support, and here and there, quite a few things actually. So it took some effort to get to this point. But yes, I mean, the routes were all there. We did the same exercise for IPv6 and then the VPN. And the next few slides are going to talk about what did we get out of this. Okay, so first let's take a look at memory footprint. Injecting 1 million route decreased the memory by close to 4 gig. So certainly, if you have a low memory platform like 4 gig, 8 gig, 1 million route is out of question here. And this platform that we used was having 32 gig of memory. The major consumers were the BGP Docker, which went to like 1.8 gig, starting with 90 MB to 1.8 gig. The SWS's Docker was the second one, and it was also consuming close to a gig. So 2 gig versus 1 gig kind of. Rest of the Dockers, for example, database, yeah, it showed some increment, but it was not as drastic as actually the BGP and the SWSs. Now, before we go to the route convergence, I would like to flash this diagram where this is a good diagram available here, SONiC wiki architecture. The circles, the ovals here are the points which we are trying to measure the route convergence. So the way we do is we instrumented BGP Zebra to just monitor and record the timestamp the first time they are seeing the route and the last route they are seeing. So basically, anytime you say, okay, show me the timestamps, it just compares the first route and the last route timestamp and tells you that how much time it took. The reason why this kind of instrumentation is required was because you have to have a specific test suite licenses from Ixia. We did not have that. And those are very specific tests which are from Ixia and not readily available. So yeah. But yes, so this experiment actually does give a good insight into what is happening in the system. So let's move on here. So the first two timestamps are coming from Zebra itself. So Zebra, we are monitoring the timestamp when the route was added to the kernel, and we are monitoring the timestamp when the route was added to the FPM SIGD. The similar thing we do in the OA. For hardware, we actually have a script to periodically check the ALPM usage, and that's how we record time. Okay, so you can see that we start with 100K 300K and 1 million, this linearly increased. But then as we went from, say, Zebra towards the Arc agent hardware, this actually changed more drastically. So as you can see, the Zebra to kernel finished in 140 seconds. Zebra to FPM SIMD was actually the one which was taking very long time. And the corresponding, the Arc agent time was also aligning with actually Zebra to FPM. And hardware certainly was following the same.
I have a quick question.
Yeah.
Those numbers are like the Zebra to kernel numbers are well outside of what I would expect for 100K routes. So I'd be interested in have a little more data about what you're doing, and maybe we can take this offline, but like,
so
100
yeah,
routes,
yeah. So let me finish. So
Sure.
I'm coming to that point. Yes. So one difference maybe in the experimentation that you were doing and what is happening here is that this is a network convergence, not just a single node injecting a route, right? So whatever convergence number that you were seeing there is like the route has to 250K routes have to come all the way from here and then settle down here like this, right?
It's not just,
yeah,
okay,
next,
so it's EGP and Zebra then. Got it. Okay.
yeah.
I understand better now.
So correct. So just because these numbers were big, we wanted to see that if we have a very simplistic topology where we are just injecting a route from, say, Ixia and then measuring the timestamp here, how much time does it take, right? And I think you would agree with these numbers. So what we saw was that within BGP, it took 20 seconds, less than 30 seconds to settle 1 million routes and send all of these routes to Zebra. Zebra also finished within 30 seconds and it sent all of the routes to the kernel. However, Zebra to FPM, it took 220 seconds. And the Arc agent and the hardware were following the same pattern. Do you agree with these numbers, especially the first two, Donald?
Yeah, that doesn't seem out of line. Something I don't know if you've looked at, but the FPM, especially the old FPM, has intentional delays to slow passing data down. Have you looked at kicking that up yet? There's a thread, an event that doesn't run it saves and doesn't run immediately. So, and it's seconds go by. So it makes it worthwhile to spend some time looking at that event and make it kick off faster and more often.
Okay, sure. I think this FPM to deep lane.
Hassan, I have a question. So the Zebra to kernel and Zebra to FPM, are you looking at the logs in Zebra, the timestamps in Zebra, and coming up with
I explained in the beginning, right, that we instrumented Zebra to record the timestamp of the route when it is being added to the kernel or to the FPM. Right.
So Zebra will start with the route add messages, right? And then it will do redistribution towards kernel and towards FPM, right? So you will have different logs for kernel and for FPM. So are you looking at those timestamps? That's what I was checking.
Correct.
Okay, but these logs are only from Zebra perspective.
Yes.
I see.
Yeah. And these are not the logs actually. These are the timestamps collected within the Zebra, the first route and the last route timestamp, and the difference. Yeah.
And one more question I had, for my understanding, this Zebra to kernel, when we send a netlink message towards kernel, do we wait for the response and then send the route add messages towards FPM, or it happens asynchronously?
It's asynchronously.
Then why would we see such a huge difference from Zebra to kernel and Zebra to FPM?
let me come back to it actually. So yeah, so so Donald, I think I get your point that I'm not sure. So this number is anyway is at least a few months back old. I'm just pulling those numbers right now and sharing it here. Recently, I saw that we have migrated to the deep lane based FPM SING-D, FPM. So that might make some difference, right? Because the old FPM, you're saying that might be delayed, whereas the deep lane FPM should be very fast.
Well, yeah, it's going to be, so the old FPM, as the route was installed in the kernel, we added the route onto
Using the hook.
list. Am I
Yes.
muted? And we added the route onto a list, and there was a specific event system that woke up occasionally and pulled items off the list and shoved it down the FPM. That was the old way of doing
Yes.
it. The new way with the data plane is that it is in line with the route installs to Zebra. So the route goes to Zebra and then it goes to the FPM and is shoved down immediately. There is no delay.
Sure.
So, but
Sure,
you know,
I
you're
can-
doing two operations at once. So it's going to be, so, you know, Zebra to kernel without any FPM might be 29 seconds. With Zebra to kernel with new FPM might, I don't have timings on that to, because you know, you're shoving the same data twice, two different pipes. So.
Sure. Yeah, maybe you can, you know, I can rerun the same test actually with the deep lane FPM and see how much difference it makes.
Yeah, it should make a difference. But I think we could also use the old way to make it faster as well. I don't think that would be hard to do, in all honesty.
Sure. All right. So essentially, you know, FPM SING-D, it's not that it was not busy during this time. So I was monitoring what FPM SING-D is doing. Majority of the time, I saw that it is either pushing to the Redis pipeline, the data, or it is actually flushing the pipeline. So this is something that we have to emphasize and zoom into because this is where the major bottleneck is. But yes, I mean, this experimentation actually gave some idea that what and where that, you know, the bottleneck is. So yeah, maybe next few weeks, I should be able to get the new data. All right. So other than route convergence,
Hey, Hassan,
yeah.
Hassan, so can you go back to the previous slide with the breakdown? Previous one. So the org agent and how these are calculated independently, right? Meaning org agent when it's 246 is not because of the previous module, right? It's not because of the FPM, right?
Yeah, it's not stacked. It's not stacked. It's in the pipeline. So yeah, so it's not that you know the total time will be 220 plus 246. No.
Oh, not 220 plus 246.
Yeah.
Sorry.
Yeah.
So for example, then total time it takes to get to hardware, is it 220? Basically adding up all these together, or
247. 247.
Oh,
no, it's not adding.
247. Okay.
247.
Okay. Okay.
Okay.
So
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 each
it's a
column
parallel, right? Kind of like.
Exactly.
Okay.
It's in the pipeline. Yeah.
Okay.
And
Thanks.
this number is actually start to the finish.
Okay. Okay. So I mean, I guess my question, another question is, we don't do we see FPM performance impacted occasion, right? Or
Yeah, so I think this is
but maybe they are all.
this is the area to look at right now, whether FPM SING-D is a bottleneck or the FPM processing inside Zebra is a bottleneck.
Okay. Okay, thanks. Yeah.
Okay, moving on. So, all right, so we hit quite a few issues. I'm just listing down a few of them. So first one was related to the kernel tuning, because the default parameters which are set up in the kernel were not designed for this much of a scale. Specifically for IPv6, we saw that the routes were continuously being deleted, and the FRR was pushing back because the route max size was set to very low number. So the garbage collector was removing the routes from the kernel, sending the delete notifications to Zebra, and Zebra was pushing that route back again. After we increased the max size, it settled down. But then when we were running the flap test, we saw that the Zebra crashed because of the netlink overflow. And the reason is for IPv4, we don't send the route deletes to the kernel does not send route delete to the application. But IPv6, that is not the behavior. In fact, that is controlled using this skip notify and dev down flag in SSCTL flag, which is set to 0 right now. So when we set it to 1, this update was not being sent and Zebra was not crashing. We were doing continuous link flap test as well. And we saw that the database Docker memory was building up. And eventually, if you run it for a few hours, you will see that, there was out of memory and database was crashing. The system was crashing actually, or out of memory. Another thing is with 1 million route, somebody want to see, say, first few routes or last few routes in the middle and all that. There is no pagination support, or there is range support for these FRR show outputs. So I think it's a good enhancement. It might be a good enhancement to have those pagination or paginated commands implemented in FRR, like show IP route or show IPBGP route, those sort of commands.
What do you mean by pagination? Because that's there.
So what happens? So pagination, I do not mean that you are showing the buffer in terms of the pages, but rather only if the user wants more data, you actually get more data from the backend and then show it. So this pagination, I would say it's a fixed record based. So the way I was thinking was, I can give the prefix and say that, show me next 100 routes from this prefix. And, it actually does that. So we can discuss more on this, but yeah, this is an interesting topic. And these are just initial thoughts, but yes. Right now, what I see is that if I do show route, show IP route, or show BGP route, the whole routing table is actually dumped into a buffer. And that buffer is actually copied, and that buffer is actually a few, maybe close to a gig actually. Yeah, so that's the problem. All right. Okay, so 2 minutes left. Maybe you can stop it somewhere here, and then we can.
Hassan?
Yeah.
So I'm not sure whether we can let us know like what hardware you guys used for the measurement of this convergence or not. Like so, because when we tested, it was for around 200K routes. Actually, it was coming around like 90 seconds overall convergence time. So which are the
yeah, so this is 8-core 32 gig platform.
Okay. And it's a modular or a single 1U box?
It's a 1U box.
A 1U box, okay.
No, not a chassis, not a chassis.
And also you mentioned like, so there were some license issues before, right? So I'm also from Keysight. So actually when you can configure BGP, right? So I don't think you need any special license for running the convergence test. Like just you can create a traffic item and then you can send the traffic, and there you can directly get the convergence stat. I'm not sure why it complained about some licenses for you.
So the specific test, I'm not able to recollect the exact name, but these are the standard convergence tests as
Yeah,
per the
7747
RSC.
maybe, the 7747 convergence test. Okay.
Yes, yes.
Okay,
You're
so
saying that I don't need a license
yeah.
for that?
Yeah, you don't need. Generally, if you have like, because you guys can configure, like you already configured BGP everything and you start advertising the routes, right? So just you need to create one traffic item and then just enable few stats, and you will directly get the convergence stat from where. Like
Okay,
once.
let me touch base with you offline in that case.
Sure.
Yeah.
Thanks. Yeah.
Yep. So it's already 6:30, so I'll stop here. And if required, we can discuss more on this. Otherwise, we already have a few topics to discuss in the next work group meeting.
Sounds good. Thank you, Hassan. This is pretty informative.
Thank you.
Yeah, thanks. Yeah.
All right. I think we can end the meeting here, I believe. Thanks, everyone.
Yeah. Thanks. Thank you.
So,
Thanks,
thank you.
everyone.
Thank you. Bye.
Bye-bye.